So, did anybody have any specific questions, specific things that were troubling or hard to grasp, or anything you liked, anything you thought was cool? Any thoughts?
I have no thoughts. My head is empty.
Okay. Let us see. I see someone typing. Potentially have thoughts. Maybe. Okay, there's a crab emote. I think that's a thought. I'll take it.
Thoughts, but crabs. Nope, no chance.
I'll take it. Yeah, sounds good to me. Okay, so let's get into it then. Can anybody describe what exactly a struct is in Rust? And why would we use one?
I guess I'll give it a shot. So structs are essentially trying to define it without using the word itself. A syntax in Rust that allows you to group other data types, whether those are primitives or other structs, so that they're easier to access. So if you have like a logically associated set of data, like a position on a graph, like an XY coordinate, you can group those together. And so you can use a struct to do that. So you would have like your point dot X or point dot Y to reference those values. So it's just a way of organizing data.
Anything else?
I mean, you can also implement functionality on the structs, so in that way they behave a bit more like classes, I guess, from other languages. So you can access the internal fields from that struct and then perform operations on them. So you can encapsulate data and functionality together as well. Oh, yeah, I'm sure there's something to do with the ownership system. But they,
yes, it does.
From what
indeed.
I've seen, they behave similar to primitives.
Primitives, how so? What do you mean by that?
Well, I mean, the way you use them, like you obviously have, like you want to reference particular pieces of data or particular functions from a structure usually. So you're not just doing like point plus point, although you can do that, I'm sure, like override operators and stuff. But usually you're like the syntax changes a bit for accessing those, but I don't know. Also me a way to structure things. Yeah.
We actually looked at it in the last book club for overriding the operator. It's not overriding the operator, it is instead implementing a trait.
Right, yeah.
Which specifically the add
is.
trait. But we're not going to get into that too deep this time. Learn my lesson from last session taking too long. Oh, yeah, I think you're spot on for everything. It's a way to group our data and also encapsulate some of that data. Like if we had a function that only takes in a certain struct, it's not much use of any other code, so it's pretty helpful to have within itself. Okay, so how do we define a struct?
Let's see. Syntax uses the struct keyword followed by a name for the structure, and then open and close braces. Then inside those braces, you would define the different fields that you want. So for person, probably like first name, last name, etc. Oh, and you need a type. You need types for those, just like you would write for like other variables.
Okay, I think that's good. Did I turn on the server again? I guess I did. I spent time doing that. Oh no. I'm gonna close this terminal.
Shut it down. Shut it down.
I think we're fine though. It's okay if it's never constructed. But let's... We don't need it for now because we're not doing any borrowing as of right now. So in this case, how do we make this struct? How do we construct the struct to get an instance?
You use the structure's name. So like you would declare it like a normal variable. So you might say let lowercase person equals person with a capital P, the structure name. And then open and close brackets or braces. And inside those braces, you're going to define the fields to the person. Like that, yeah.
Oh, okay. I don't know how to use Vim apparently because I did FTO instead of slash.
Wait, what is that? What was that autocomplete though? Like, what is that?
Oh, it's just quick fix.
Oh, okay.
You could do lots of stuff
That's like
here.
it's a VS Code thing.
Yeah, the Rust LSP thing. It's not a thing in other languages, as far as I know. It could be, but I've never seen it.
If my, I think my Vim has the Rust LSP enabled, but I just don't know the shortcuts.
You can do tons of cool stuff with, I mean, I've shown them off, but another thing I've done is like we say hi is 32 here, and it's going to say, okay, that's not a thing, but we can create a GitHub issue. That's the most important one. We can also convert the base, extract into a variable, create field. Whoa, amazing, it worked.
Neat.
So yeah, it does all that. We're getting a lot of unreachable code, of course, because we didn't actually fill this out.
Yep.
So let's give it a cool first name. What's a cool first last name to pick?
First and last name. Sven. First name.
Svensson.
Yeah, I just Sven.
Oh, Sven? Okay.
Yeah.
I mean, sure. Let's go for it.
Sven squared.
How old is Sven?
Sven is I don't know, 99.
Oh no, getting kind of old.
Nah, 99's still young.
Okay, so how would we go about doing something like getting the age out of this? How do I read the age?
Should be able to just type person dot and then the field name, so person dot age.
Indeed.
And then you could print that out or do whatever.
I'm pretty sure it'll do, if we make a function like this, it'll generate it for us with no. Is it? Nah, it's not going to make the function for us. Maybe it's because it thinks it's we're trying to do the macro. Oh, there we go. Perfect. Yeah. Generate function.
What?
Age isn't defined, so it doesn't do anything. But if we did instead person.age, pass person.age, and then we say like let age I32. I guess we could also say unit, just so it knows exactly what to do. But we can do like, yeah, let's just do I32 so it has something to put there. But yeah, generate, bam, it's done. Amazing.
Cool. I gotta learn all the LSP tricks.
Yeah, it's super fancy, super helpful.
Maximize my productivity.
Yeah, so in this case, let's actually leave this here. And we're gonna stop the LSP. If I print this, let's debug so we don't have to do that. If I debug print age, am I allowed to do that? And then after that point, can I do these things? Am I allowed? Does this compile? And if so, what does it print? If not, why not?
Yes to the first two, no to the last debug. So in the case of the first two, you're essentially passing integers into the debug macro with age and person.age. And by default, the integers not inherit. What's the word? Derive or right? So you can do that.
You cut out, sorry.
Person as a structure. Oh, sorry. Person as a structure can't do it because it doesn't have the debug rate, I think. Integers passed into the first two should.
Yeah, exactly. Age is an I32, so it already has debug derived on it. All of those primitive types will, but person does not have debug implemented. So we need to implement that. And how would we do that?
I think you can use the derive macro or trait or whatever it's called. It's like hashtag derive, hashtag open and close square brackets, and then inside the square brackets say derive debug. I'm sure there's another way to implement it, but that's the only way I've ever done it.
I think that's the best way to do it. If there is another way, I don't know. Oh yeah, well yeah, there is another way. You can
like if
still
you wanted
manually
a custom
implement it.
debug output. Yeah, like you could do a manual output, so it doesn't just. I think it just lists the field names and values by default, like in a group of lines, like it does one line for each field.
Yeah, I wonder if you can implement. I know you can implement it, but I'm just looking on the side to see what required methods. Oh yeah, so if you do implement it, you have to implement the format function. So yes, and don't worry about that here because that only matters if you want a custom implementation. So if you want to use that default implementation, you can derive it and it will automatically, or it'll use that default implementation and work for you. It'll be automatically implemented. I'm not exactly sure if that's the correct terminology there, but yeah. And just since we are talking about LSP stuff, I wonder if there's any way we could do that.
Do what? Do the manual implementation.
Am I doing this wrong? Oh, okay. I was.
What are you doing?
Apparently, I'm super rusty at Vim because I was doing like 11 GG, which goes to the absolute 11th line, but I'm looking at relative lines, so I need to do like 11K.
Yeah.
So, wow. Okay, but I wonder if we could implement that. Well, it looks like we cannot, but if we go here instead, we can.
Yeah.
And then even if you don't, and you're just typing it out yourself, or you're just going through derive, we're like, okay, derive. Ah, I thought it would fill it out for me. Oh, well, that works anyway. There we go. And now this works. So you're exactly right there. What if we wanted to use println to print person? How would we go about that? Probably shouldn't have asked like that, since now you know there's probably something wrong with it. But is this valid? Will this compile?
Nope.
How could we change this?
Println has to, or to use println, the macro, you have to implement the format display trait, which is there might be a default implementation. I'm not sure.
In this case, there is not.
I think you have to do. Okay, yeah.
That would be for custom implementation.
Yeah.
What if we need to use println to, instead of printing like this, we want to debug print person in the println?
You can use the debug. What is there's like a format string debug shortcut. It's like colon question mark inside curly braces, instead of just leaving the curly braces like blank inside. And that will refer to the debug like output, I guess, when it tries to print.
Yeah, let's get rid of these ones, just so it doesn't break anything, because we to do. But oh, age is not a thing. Of course, we remove that. And it doesn't compile because borrowing error. But ignoring that.
Yeah. Debug apparently, what is it? It doesn't borrow, it moves into debug, so you always have to give it a reference.
Yeah,
you
exactly.
Have to borrow.
Well, println implicitly borrows, but
is that what it
debug
is?
doesn't. Most functions do not implicitly borrow, but if you look at how
the println,
I guess I can't like go to definition right here, but yeah, println is special. Pretty much everything else is not going to do that, but specifically println does it as a convenience thing.
Good to know.
Yeah, so debug does not. It does take a reference, I believe. Oh, maybe I can't go to definition because I turned off the language server, of course. Who knew?
Blast.
But yeah, looking here. Is it going to show me the definition? I guess not. Okay, we might not want to look at any of this now, but let's look at the println one, see if we can see. Yeah, so does it borrow it? I thought it did somewhere. Okay, well, I am not immediately seeing it, so I think we're going to run away.
I absolutely know it does. It behaves like it.
It implicitly borrows. That's all we need to know. I thought there would be like an obvious borrow, but we're going to ignore that for now, because that is for future use if we ever get to it. Oh, it's not going to tell me. What if I do this? Does it say no? Oh, we can inline macro. Oh well. Oh, maybe it's both of these. Like we go to println, there's another macro in here, which is format args, which we can't go to, so we're going to ignore it. Okay, I'm going too much into it, but yeah. Okay, do you remember how to pretty print this output? Or pretty debug print?
What do you mean by that?
Pretty debug print.
I mean, you can do individual fields stuff if you want.
Oh, well, there's a way to print it out and move each of these fields on separate lines. Like maybe we don't want to look at it like this.
I don't know. I thought it did that by default, but maybe that's just the debug macro.
Oh, well, debug isn't pretty printing.
I don't know what I mean by pretty.
Okay, well,
Is like the debug lists each field on a separate line with the field name as well as the value, which I would consider printing it.
yeah, this is pretty print.
Oh, okay.
It does some extra stuff in here, like it shows the line number, the variable name, but
yeah.
Anybody else know? Well, pretty sure we add a hashtag right there. It pretty prints.
And so wait, what does it do if you don't do the
It prints like
symbol?
this. I'll do both right after another.
Oh, it just does it all in line. Okay.
So if I run this,
Got it.
see how this one is all in one line, this one is, each field has its own. Yep.
Yeah.
And it's important to know that? Or do you know why it's important to know that? Or how to pretty debug print with println instead of just using debug?
I mean, it's convenient if you need to do other formatting or include other strings that aren't just debug prints. I can't think of anything else. It helps for readability, I guess. Maybe
So
if you're putting stuff to logs.
if this one println prints to standard out, do you remember where debug prints to?
Yeah, debug goes to standard error.
Yeah, exactly.
I assume you can redirect with println, can't you? I haven't looked into it yet.
I think there is println, which goes to standard error. Yeah. So yeah, you're not forced to deal with the, maybe it's not dealing with, but you're not forced to have the variable name and line numbers if that's something you're not into. Okay. Let's not spend too much time here And let's move on. So what if we want to change this person's age? Like, what if it's their birthday? What do we do? How would we change their age?
Well, first you need to make structure mutable. They let mute person. Then you can go down past the initialization and say person.age equals 100. There you go. You updated the age.
Yeah, let's go. And printing it out just to show. We're getting all of these amazing warnings. I don't see it printing. Oh, I forgot to save. Understandable. There we go. 99, 100. Amazing. So how would we instead... Well, let's ask some of the fun borrowing questions while we're here. Or maybe not. No, let's wait for it a bit later. How would we go about writing a function that takes in a person and then changes their age? Like, what if we want to do this every time? We don't want to have to manually update their age. How would we do that?
Do it every time when what happens?
So every time it's someone's birthday, we have to manually change their age and make them mutable. What if we don't want to do that? How could we write a function to do that for us? And how would we do it?
Yeah. So add a function to a structure. You need a new syntax, and that's the impl keyword, IMPL, and then the name of the structure.
What if we take a step back and write a function instead? We'll get to that.
Oh, I see. Yeah, you could write a function that takes a person as a parameter. FN.
No.
This isn't JavaScript.
I'm sorry.
Get the TypeScript out of your head. We only program in Rust.
Okay. So we're taking a person. And then what did you say?
Guess that you would need, if we're just going to increment the age, you would just need the person, but you probably need to make that a mutable reference if you actually wanted to update the original, if that's what the goal is.
I mean, what do you think?
I would use an impl to add a method and not do it this way, but yeah, you can do it with a mutable reference person.
Okay, so then we take this and put it in here, right?
Yeah. Are we setting that to 100 or are we just increasing it every time we run the birthday?
We are setting it to 100 right now, but we can add one. I think that's better.
Every birthday you gain 100 years.
You just turn 100 every year. You never die.
Oh, see, I told you 99 is still young.
Yeah. So does this compile?
No.
Why not?
Maybe. I don't think so. I think you have to give the argument to birthday as a reference. The ampersand person.
Like this?
Yeah, I think so. Because the parameter states that it's a mutable reference. So I think you have to pass it as a reference.
Like this?
Yeah.
Okay. Let's see if that compiles.
Uh-oh.
Looks like it expected a mutable reference.
Types differ. Oh, do you have to... You don't have to specify like ampersand mute in the argument, do you?
Yeah, you do.
Huh. Forgot about that.
You're passing a reference. This is a mutable reference you're passing to this function. If you pass a mutable reference, the mutable reference doesn't expect to be changed.
I was for some reason thinking that since the variable was declared as mutable, whenever you pass the reference to a function, it would consider it a mutable reference.
Consider
But I guess it makes sense that it doesn't.
something like this. So we have like P, which is reference. That's not a reference. Reference to P. Or sorry, person. Person. Reference to person. And then we pass P. Does that make it more clear why we would want to do that? Where borrowing is immutable, so this P says this will never change. This reference is a reference to person, which is immutable. And then we're passing it to birthday and then changing it.
Right. So yeah, borrows you always have to specify as mutable or immutable.
Yep, it's just the method syntax.
I forgot that's how it requires the definitions of like parameters, I guess.
And verifying, it expects this to be mutable.
Yeah.
So this will work if we do this.
Yeah.
So let's verify this runs. And it does. But getting into another question, is this valid? Will this compile?
No.
Why not?
The debug moves the structure whenever you execute it. So in that first debug, it would move person into the debug function, and then you wouldn't have access to it anymore after that. You'd have to pass a reference debug statements.
So you're saying all of these debug statements need a reference?
Yeah.
What did I do? Oh well, I'll just do it manually.
You manually.
Gross. Okay, so you think this will compile now?
Hold on. No, wait. I don't know if this counts as having multiple mutable references with the setting p equal to the mutable reference of the person.
I don't see
Or rather, like
multiple
you have
mutable
a
references.
you have a mutable reference, but then you have another mutable reference, right? With person that you use after you establish the mutable reference.
There's only one
think that's
mutable
gonna
reference
throw an
here.
error.
It's right here. P. E is a mutable reference, but the
Right,
rest of
but
these
then
are
you
not
also
mutable.
Right, but I don't think you can't have a mutable reference and an immutable reference at the same time, right? Am I remembering
To
that
the
wrong?
Yeah, you're right.
But do we have that here? Does person count as a mutable reference and then P as a mutable sorry. Does person count as an immutable reference and then P is a mutable reference to person?
Person is a mutable person struct. It is not a reference.
Okay. And in that case, I think it'll be fine. Wait, does the birthday? Yeah, we're passing a mutable reference to that. So if we don't have a error from multiple mutable references, that should be fine.
There is an error, but it's not from multiple mutable references.
Uh-oh.
So
An immutable borrow.
this specifically. And then to address this piece as well, we're not moving person by doing this debug. Since age implements copy, it's a
copy
number.
anyway.
We're taking this age. We don't need to do this because it will copy that number.
It would work if you did, though.
It would.
Okay.
It would work if we did, but it was not our issue.
Right. Immutable borrow.
So let's remove the offenders here so it's a little bit easier to read. So looking at this, we have person, which lives for the whole main function. Then we have this reference P, which lives all the way till the end here where it's used in birthday. And then we have person age.
Oh. Wait. I still don't see what's wrong with that. Use of borrowed person. But why does it matter if it's copied anyway?
I wonder if we can take this into Aquascope to see why. So since we have this immutable reference, that means we're not allowed to do anything with person.
Reference.
Like we have person. We can't do anything with person because we have, sorry, yeah, a mutable reference. Sorry if I said mutable or immutable. This is a mutable reference. So that means it's the only place we're only allowed to use P for the lifetime of P. We're not allowed to use person anymore. So
because is that not the same thing?
person.age is a piece of person. So we're not allowed to use that.
So it's...
If we did this, it would be the same issue. We're not allowed to use this person struct or any of its fields. Or from this line.
So this is what I was thinking of when I was thinking of a mutable reference and an immutable reference at the same time.
But well, it isn't a reference. Person's a known value.
Error debugger or the compiler say.
What'd you say?
What is the compiler error that it's giving for that?
We cannot move out of
Just wanna
person
see
because
the
it's
wording.
borrowed. So in this case, I did change the error because debug is causing a move now.
Okay.
And then if we do this becomes an immutable borrow. And previously we had .h, which in this case is not
Immutable
a borrow,
So
but we're
what does
using
immutable borrow mean?
an immutable borrow is an ampersand only reference. So we have let's say R for reference equals and person. This is immutable. It cannot be mutated.
Okay.
And here our issue is not that person is being borrowed here. It's that person is borrowed here and then used during the lifetime of P. So from line 15 to line 19, we aren't allowed to use P anymore. So let's see if we can open up Aqua's. And see if I'll let this load on the side while we, oh, well, it worked, maybe. Maybe not. Oh, yeah, there we go, perfect. So we have this person, so all of these paths, so looking at person, we're allowed to read person, write person, and we also have ownership permissions for this. So as well as for all of its fields, so first name, last name, and age, they're all owned. But once we have a mutable reference, we need write permissions and read permissions. So at this point, person loses all of its permissions. So all of its fields, everything within person loses all of these permissions. So you can't read it, you can't write it, you can't exchange ownership. And then that read and ownership moves to P. And then write permissions move to ampersand P. That's not ampersand, sorry, asterisk P. Does that make sense?
I think I'll have to look at it later. I don't see what the difference is.
Okay. Well, just know anytime you have a mutable reference, you're not allowed to use anything except for that mutable reference. So we're not allowed to use person until the end of the lifetime of P. Okay, then let's move on to the fun part. How would we turn this into a method for the person struct?
You can use the impl syntax. So IMPL, person, capital P, and yep, brackets, and then you're going to define a function, fn, inside there. One important thing though is instead of passing in the person as a parameter, you can use self to refer to the instance of the object.
So we should change person. So what I'm highlighting here,
Yeah, you can
to self.
Yeah, you can replace actually all of that with self because Rust
whole thing with self?
auto-completes. Yeah, Rust auto-completes like the self. So what just self means in there is actually it's like self colon, and then it would be typed to like the self type, capital S, I think. Or it might be
So
a
self.
borrowed self. Yeah, it might be like a reference to self, one of those.
Well, let's look back at the original. What do you think it should be?
I guess it does a mutable reference to self.
Yep, exactly. If we gave it a an immutable, well, if we just gave it ownership at that point, then we wouldn't be able to change it. I guess we could, because it has ownership. We could make it mutable later. But
you would lose access to it. You'd have to return it, right? If you wanted to do anything with it afterwards.
yeah, it's not a particularly helpful function because we just lose. You age and then the person gets deallocated. RIP.
So
The person gets deallocated. Yeah, so exactly. We actually could do it this way. It's just interesting to go about it this way, in my opinion.
yeah, non-idiomatic.
So
That's the word you're looking for.
instead, we're gonna do mutable reference to self. And how would we change birthday here to fix this?
You would run person or p, I guess at the point dot, and then you would use the method birthday without any parameters, since self is passed in automagically because it's from a method of the structure person.
Does this work? Will this compile?
No. So in the method birthday under person, you have to specify person as self. We don't have the person parameter being passed in. It's now called self.
Nice. And what about this?
I think that would work. Birthday used as a mutable reference. Yeah, I think that's fine.
Okay. Let's find out.
Uh-oh.
Uh-oh. It's fine.
Oh, okay.
Yeah, it passed. It's fine.
I can't tell because it scrolls, but
Oh yeah, it's a lot because
We
we're
don't-
not using these
we don't have
fields.
like 60 FPS, so it looks like there's a bunch of errors, and it's like, oh, it's okay.
No, they're all warnings. I could probably just remove unused or tell Clippy to stop.
No, the warnings are important.
So we can do that real quick. So we have warn dead code.
Oh,
We're gonna allow dead code. We like dead code. And that should work. I actually should change these up. Oh no.
Oh, can you make it global?
Yeah.
Or can you only make it global?
You could do either one. You could put it right above each instance where something's not being used, but I would prefer, well, that's not how you do it. It's like something else.
Would be
It's like, what's a global attribute? Oh, it's the other way around.
hashtag exclamation point for a global attribute. Is that what it is?
They're never run. Okay, so dead code, so it should be, yeah, that makes it for the entire file. And if you do an attribute like this, it's just for the next line. Okay, there we go. So I did it correctly. I didn't need the clippy qualification. So here, yeah, see how it's not doing it here? Maybe it makes sense to start the server to look at it. So if I remove this, and if I add it back, and if I instead do this, it works for one but not the other.
Ah, cool.
So this is just to remove those for the purpose of our demonstration. Okay, so this does indeed work. And space repetition, does this work?
No. Can't use person after the mutable reference to P, or mutable reference of person assigned to P. I don't know why. But no, you can't do it.
It just doesn't expect to be mutated. So like if we decided to pass person in and change it, then we don't expect it to change here.
Oh yeah, because isn't it because you have a mutable reference and an immutable reference, right? The immutable reference is person, and then the mutable reference is P, but you can't have them both at the same time, right?
Yeah, imagine something, I guess that doesn't make much sense, but for example, this one I don't believe would be, like if we took a vector instead of a person, and then we push to the vector, and then this did something here, then this pointer could be invalidated. I'm not exactly sure. I will look into it because I am questioning my own reasoning now. I will let you know afterwards. But yeah, let's move on to another piece. And one thing to notice is we set the whole struct to mutable, and we can't set specific keys to mutable. We have to set just the struct. What if instead of doing this whole thing with creating a person, we wanted to make an associated function that created it for us? How would we go about that? So say we have this. What would the signature be?
You would probably want to pass in the parameters to the fields you'll need. So first name, last name, and age. I guess you don't have to. You could just hard code them all, but if you did that, there'd be no point to the new function.
Maybe not.
Or, I mean, there would. Like, you could use the new function to initialize new persons, but
Yeah,
So,
we're not
yeah,
getting
it would be
into
first name.
public or private fields at this point. So at this point,
it would be first name string, last name string, birthday, year, I-32, I think, or what was it?
it's a U32 because you can't be
U32.
negative age. Or we could say maybe
Says
the new
you.
person is 0 years old. But let's keep it this way.
Yeah. Oh, you also need a return type.
And what would that be?
Person. Capital P, person.
Is there another way we could write that?
Could you use self?
Yep.
Oh, huh. They have learned. Yeah, then you would want to initialize it just like we did before with the syntax. Or I guess you can use self. That makes sense.
Yeah, you could use either one, but just letting you know. So we
is
could
self like an auto-populated type, I guess. Like the capital S is going to be the type, and then lowercase s is usually going to be like a parameter, like an instance of.
Yeah, self specifically is the name of a first argument or first parameter to make it a method instead of an associated function.
Okay.
But yeah, self is referring to the struct that we're implementing on. Or the struct where the impl block is related. I'm not entirely sure how I should word that. But yeah, how would we fill this out?
Rust seems to really know itself and how to read itself. That's very true. Rust basically infers a lot of stuff so you don't have to write it down to make it easier on the programmer.
Yeah, it's pretty helpful to have different associated things like in this case, I will turn on the server just to show. Oh, I should not be doing this in this block.
Embrace.
But yeah, see how self is defined as a person? It just is a person at this point. So highlighting here, you see that self, and person are all highlighted.
Ah, cool.
But here, self is this self. Yeah. And we also have all these functions, like birthday. So yeah, how would we instantiate a new person here?
Fill in your fields. So first name, and then there's a shorthand syntax. So you could just list the first name, comma, last name, comma, birthday, since the names of the parameters are the same as the names of the fields.
How would we do it
Otherwise,
the long way?
The long way, you would write out the field name like you have for first name, and then give it a type. You'd give, colon, and then the whatever value you want to set it to.
I feel like give it a type is a inaccurate way to phrase it. Just
in this case,
pairs.
yeah, I was thinking about the definition.
Yeah, it's a value instantiating struct.
It's just a field name and then a value.
I can almost guarantee it's going to tell me, yeah, it's saying, hey,
Yeah.
you shouldn't do this because you don't have to. But also, bam.
Bam.
I thought it would be smarter or smart enough to do that, but I guess not. Oh, it's not age. That's why. Why is it adding age? Oh, because this is called birthday. I called it. Wait, I called it birthday and not age. Okay, makes sense. Makes sense. So let's try again, but do the correct thing. What if? Oh, I thought that would fill it out for me. That's so sad. Oh well. Let's change this to age. And then... yeah, it is smart enough. I just did it wrong.
Cool.
So yeah, we can... how would we now replace this instantiation with person?
Now you can run person :new, access the struct function. I don't know how you phrase it.
It's an associated function.
It's associated function. It's not on the instance. It's on the struct. And then you give the parameters, first name, last name as values. You don't need to specify the field names anymore. Or you, it's auto completing it for you. But yeah.
Yeah, so here, I guess you could argue that this doesn't bring anything new, but... oh, depending.
Okay,
So
yes.
imagine we had private fields here. We're not allowed to set these ourselves. We can't construct this ourselves. We just can add here. So this is another use case for that. So it's not useless necessarily, but also not something we really want to get into at this point. Yeah, so...
I mean, what I found most useful is when you have a set of parameters you want to give to a structure, but you want to generate or do some sort of calculation to set up some other fields that are useful, but they can be derived from like maybe you just need the first and last name, and you want to construct a third parameter that's first plus last name, and it's like first name comma last name as a separate string. Then you can do that without needing to pass in a separate parameter.
Yeah, I think that's a very good use case as well. How would we go about, instead of using p.birthday, how would we directly call this function on the person field and get around the syntactic sugar?
I guess you could call capital P person : birthday, and then pass in P.
Like that? And the question here is, does this compile?
I don't know. I've never written that. I've never written it like that. It looks like it should work, but I don't know.
So birthday takes a mutable reference to self,
which we
and you
have.
said self is equivalent to self, which is person. So do we have
Yes.
a mutable reference to person here?
Yeah.
Yeah,
we do.
exactly. So
Fingers crossed.
this does indeed work. Yep, it passes. But what if we pass in person instead? Does that work?
Oh, that's a mutable reference.
It's a mutable reference?
Or immutable, sorry.
Is it a reference?
Oh, it's not a reference either, but yeah. So you would need to pass it as a reference, which you can't do because then it would be an immutable reference as well.
Why can't we
Right.
just make it an immutable reference?
You mean a mutable reference? Or
Why can't we make it a mutable reference? Yeah, sorry, we need to talk slowly.
Yeah, it's hard to tell. Because we already have one, and you can't have two at the same time.
Would we have two at the same time?
Yes. Shoot. I don't know. I don't know if the lifetime of P like immediately ends if it's not used. If that's the case, no, technically you wouldn't. It would just end its own lifetime as soon as it's set, since you don't use it after that, after line 13.
The lifetime of a reference is from its initialization until the last time it's used. So in this case, the
Okay.
lifetime of P is just this one line.
Then I think it'd be okay to have a mutable reference to person like that. Yeah.
Yep, it's fine.
Okay. Yeah.
And just to show that it doesn't work like this, it does not work.
Yeah. That's because it's not a mutable reference.
Yeah, it's just important to know this piece, like how it's working under the hood, the syntactic trigger, because otherwise it's more confusing to see why certain method calls work and other ones don't. Because it's implicitly borrowing.
Yeah, makes sense. The more you know.
Okay, so what if we want to instantiate a person from this other person? So like person 2 is equal to a person. Is there any way we could do this in a shorter way than instantiating all the fields? What if we just want to change one of the fields? Like we want to change first name to, or like this person, Sven gets married, changes their last name to NEVS, Nevs. Because they wanted to reverse their last name, I guess. Is there any way we could go about taking the rest of person?
I think you can use an ellipsis or 3 dots.
Three
I think
dots.
it'll do it.
And then
so.
just like this?
Yeah, I think so.
Okay. Anyone else have any other opinions?
Oh, you might need a semicolon after.
Semicolon at the end. Okay, not hearing anything else, but let's see what it tells us. We're missing fields. So we do need to tell it what to copy or what to spread. Okay. I guess it's not spread in Rust. It's something different. I think it's called like struct copy syntax. Something very long for some reason. Yeah, I'm not exactly sure what it's called, but something longer. And the running this will show us a different issue that I did not save. And this will show a different issue after saving. Well, the issue is I decided to stop this thing, but here's another issue. So it expected 2 dots, but I got 3. So I'm not the only one doing JavaScript here. Yeah, it's 2 dots.
Oh, okay.
It's kind of like if you think of like a range, like we do 1.2. That's a range when we're skipping anything in between.
Struct literal update syntax that you were looking for.
Oh yeah, it's so easy to remember. Struct literal update syntax.
Of course.
Mhm.
Yeah. I'm scrolling through the operators section of the Rust, and it's pages and pages long.
Okay, so at this point, is it okay for us to use person? Are we allowed to use person after this point?
Probably not. Probably moved everything into the new one. So unless you pass them as a reference to the person to initialization. I don't know if you can do that with the struct copy syntax or whatever.
Well, it doesn't take a reference, it takes an actual copy.
Then yeah, it must be moving them. So,
Yep, in this
I don't think
case,
you can.
we can't do it because we partially moved.
Partial move.
Yeah, this part here, this last name, is still valid. Sven's still valid because we didn't move it. But this struct has been partially moved. So we cannot use it anymore.
Can we access just the first name? Or, yeah, what hasn't been changed? Like if we did ampersand person dot name or first name?
I did not person. First name, yeah. Well, first name has been moved into person too.
Or
You want last name, you mean?
last name then, yeah. Because that's the one that hasn't been overwritten.
Let's see.
I'm just curious.
Yeah, it does. It's okay because it has not been moved.
Oh, that's interesting.
So
So it is important that it's a partial move, not just like a full move.
it is important. So what if we do person.birthday? Can we do that?
No.
Why not?
Because the age has been moved. It's person two, so you don't have an age to operate on anymore.
Did we
And
move
maybe
it?
they're, yeah, with the dot person, age was moved.
So you're saying this would not compile? I'll take that as a maybe. But looking at this does compile.
Oh, sorry. Did I not? Did
Oh,
you not
I
hear me?
didn't hear. Sorry.
Sorry, I
You
must have cut out. Yeah. Yeah, I said yeah.
Okay, so the answer to that is it does compile because you remember
That's weird. Oh, integers
numbers copy.
Okay.
So we're allowed to do this copies. So in this case, does this compile?
I guess so. I imagine the methods, there's nothing to move with methods, so you should still be able to access the method, I would think. And then since it's operating just on the unmoved age, I think it'd be okay.
Let's see. I have a different opinion. So we cannot because
we're
able to use person.
Stealth.
Yeah.
Yeah.
We're able to use person.
Internally.
We're using self. So we are unable to do that. because we're using self. Yeah.
That makes sense.
So then, what if we, instead of a person, let's do a point like you were mentioning. How would we make a tuple struct?
Tuple struct, you just mean when you don't define field names.
Yeah.
So it'd be like struct point parentheses, or I think it's just parentheses, and then the types you want would be like U32, U32, or I32.
I went with I32, but yeah, same difference. And let's get rid of this for now. How do we instantiate this?
Remember, if you can use I think you would just have to do like point and then open curly brace. Is it parenthesis? I saw that.
I don't know.
I bet it's
It is
parentheses.
Yeah, just like a normal tuple
Yeah.
with parentheses.
Okay. And then you'd give it the values in
Yeah.
order that you want.
And this time it is in order, whereas before we could have put age first, last name first, first name first.
Mm-hmm.
So is this valid? Both of these are numbers and they both copy. So can we copy the struct?
I think so. I don't know if there's a separate attribute you have to derive though. Oh,
There's something called, I guess I need semicolon there. I don't know why, but I guess you need one after here for a tuple struct, but not for a regular struct. I'm unsure why, but yeah,
it's
this
like
is a
an
move.
expression.
Point does not
instead
implement
of
copy.
Copy. What it is. But you can derive it automatically, and because they're all or all the fields are copyable already, then it'll do it for you, I guess.
So then
Because I don't
does
think you
this
can do
compile?
that
Oh, sorry, go ahead.
if I was gonna say I don't think you can do that if you have a field type that doesn't already implement copy. I may be wrong. I don't know.
You're right.
But I think that works. There might be another attribute. I bet there's like a partial copy or something as well. Oh, clone.
Clone's required by copy. So we need copy and clone to be able to copy. And then after this point, we'll actually run the code. We get 0, 0, and it works. Do you know why, or do you have an idea of why you have to derive it on a struct, but not normally?
You mean like with the primitive types?
Well, deriving here, what's the point? Like, why do I have to derive copy and clone? Why can't I just do it? I don't have to derive copy and clone for numbers. They just have it.
Well, I mean, the number types probably do already, like in their definitions. They probably implement those traits.
Then why did
I'd
the
assume.
Rust team decide, okay, let's copy clone automatically if they're all
just-
there?
It's probably just a what do you call it? I don't think it's like a performance thing, because I don't think like the actual deriving of those would be like a big cost in the compilation process, but it's probably so you don't accidentally end up copying things all over the place accidentally. So it's more like a idiomatic decision.
Well, copying
sure
things
you're
if
writing
they're
good code.
all copy, like that's like a language feature. Like we want to copy numbers because it's
Right,
overall
but
fine.
It's if you apply that to structs, which can be larger than like regular integers and everything. If you have a large struct, it is going to be a performance hit to be copying that all the time, as opposed to simple integers, which like all of the basic integers and like Boolean and stuff that implement it by default.
So how much bigger is a struct than two numbers? Why is it that important?
The thing is, it could be infinitely big. I don't know what the actual limit is, but you could have hundreds of fields or something ridiculous, I'm sure.
Well, it's as big as its biggest item, or like that's for an enum, sorry. But yeah, here it's literally just two numbers, so it's two numbers along with any like pointer stuff going on there. So here, just like how you have an array that's like 20 billion long, you're allowed to do that. There's nothing stopping you, and you're allowed to copy it. But the reason why is if I use something like this, now it no longer implements copy and clone, so it causes some like stability issues in your API. So you have to specifically say, I want it to copy and clone.
So that's just when you have a field that needs to be like heap allocated or something.
Yeah, this does not
Is that when
implement
it's going to
copy.
cause an issue? Yeah.
Yeah, and then if I change that, then it's kind of inconvenient because it breaks like pretty much everywhere I used it.
Okay.
Yeah. Okay. Let's do one more final example and then end it off. So going back from our point, we don't need that anymore. How would we define a method that compares ages? So we want to see who's older and give their name. I just care about the signature here.
It depends. So I guess there's two ways you could do it primarily. One would be to have a instance method where you would pass the self as the first parameter. And in that case, you would apply it like you would have the instance of person one, let's say, and you would say person one dot older, and then you would pass it in a reference to another person, let's say person two, and then it would return the name of either of them. Or you could have it as I forget what you called it, but like an implementation method. So a method on the
Yeah,
type,
just a
the
method.
struct itself. Yeah. Without passing stuff into it.
Oh, that's an
And
associated
then
function then.
Associated function. And then you could pass in both persons as probably references and compare them and then spit out the name. But I don't know which one's preferred.
I think the mindset behind having methods in the first place is for something like birthday, this is only ever going to take a person. So if we leave it out in the open, is there really a point to just having a function that only takes one specific type? Like if I made another type called person2 with the same fields, it wouldn't be allowed. So if we do this instead, typically it makes more sense, and then it encapsulates that logic within the person itself instead of having to export these functions and use them elsewhere. So I personally prefer using a method for this.
I don't see the difference. I wasn't talking about like exporting it from the class. It would still be like an associated.
Oh, doing it
function.
associated. Well, that would just change how you're going about calling it.
Yeah. That's why I said I don't know if it matters.
Yeah.
Or if there's a preferred way of doing it, but you would accomplish essentially the same thing.
Well, yeah, it would be equivalent to saying, yeah, I guess it's pretty much preference. Like, thinking of max as an example. If we do 5.max,
Yeah, that's actually what I was thinking
10,
of.
that's something you could do. You could also import CMP and do 5 and 10 like that.
Yeah, I think I would prefer the associated function method, or I think I would prefer using an associated function because I don't really like the way it writes out as, like, for the math functions at least, like having a number and then calling max on another number is kind of strange to me. Like, it looks strange. Like, it's clear what's happening, but it's just kind of bizarre. Whereas if you have a function that's like person dot oldest or older or something, and then you pass it to persons, it's like, okay, well, it's a bit more clear in my mind that they're both parameters to this function, whereas the max on like the 5 here is calling on itself and then checking against another parameter, which I don't know. It just doesn't gel with my mental model as well, I guess.
Yeah, I think it's a totally valid opinion. For numbers specifically, I think I go for the dot max a lot of the time because I'm lazy and it's easier to do. But CMP is
that's what I do as well. It's especially weird on integers or numbers in general, where I don't think of them as objects all the time. And so being able to call a method like that is sort of jarring when reading through code.
Okay.
But yeah, I guess to implement an associated, we go back down to the definition. I would just use the older, and then you would just put person1 : we give it a type of, I guess, a person reference. So ampersand person, and then we have person2 with the same type. And what were we returning? The name or the actual object that's the oldest?
I think either's fine. Let's just say we do the name.
Okay. Then yeah, it'd be a string. The less string.
Maybe a what string?
Capital S string.
Okay. Yeah.
Clarify.
Yeah, I think that works out.
And then I guess I would change person1 if you have person2 as self.
I just did that for
Why?
fun.
Okay.
It is
yeah.
slightly shorter, but I don't know if we
Yeah.
care.
No, it's fine. Just as long as it's consistent. Like, it's just unacceptable to have one as self and one as person. But yeah, you would compare the ages. So
Yeah, we don't have to get
person
into
one. Okay.
doing it. I was just going for the actual
Signature.
thing, and I don't want to take us too long again because
Yeah, fair enough.
we're like an hour and a half at this point, I think.
Yeah.
So yeah, we're at exactly an hour and a half. So I'm gonna end it there. And I am going to, for homework, we have the next chapter as usual, but we're gonna wait until the new year, so the 3rd, to start back up again for the holidays. And feel free at this point, any final questions, any feedback, please let me know.
I can't believe you're assigning us homework over winter break. Come on.
Yeah, I know. At least I'm not making you go to school over winter break.
I guess. It's okay. It's not that long of a chapter, is it?
I have no clue. I haven't even looked.
Chapter 6. It looks pretty short. It's enums and pattern match. That's fun.
Enums, yeah. Your favorite if
Ooh, and
flag.
finally, the match statement.
Oh, we go into options. Options are great. I love options.
Yeah. I'm growing to love them.
Stuff like this is beautiful too, like IP address here. I don't typically end up doing anything with IP addresses, but things like ports in JavaScript where you can do whatever you want with a port and give it a completely wrong number. But in Rust, it's just like, okay, it's impossible for this to compile if you type in the wrong number.
Yeah, strongly typed languages where it's at. I do so a lot fewer mistakes because the compiler catches them for me way earlier. Yes, Rust always knows it's watching you.
I'm much happier with these ones rather than ownership, the most scary chapter, even though we're going to go over ownership again with enums probably.
Yeah.
We're definitely going over ownership again. It relates to literally the whole book, I'm sure.
It's a fundamental piece of how Rust works, so you can't really avoid it.
Okay, so my homework and your homework, extra credit, is figure out why it's bad to have use values when you have an immutable or a mutable with an M, a mutable reference.
I'm sorry, could you rephrase?
Why can't we use the owned value or any other references if we have a mutable reference? We must find that out for next session.
Okay.
Because I know that's a thing, but I forgot why. Or questioned myself why. Nope, next time we're just doing chapter 6. You can read ahead if you'd like to.
Do it.
Okay. I'm going to end it off here unless anybody had any final questions or anything. Or feedback. Yeah, there is a copy.
Oh, yeah.
Yeah, thank you.
The Rust programming language. We're on chapter 5, or we just finished chapter 5.
Yeah, and there's recordings for all of the chapters up to this point on YouTube if you are interested in watching.
Yeah. Oh, did you actually copy paste that example that we were having issues with, so I can like put it in a file so that there's a chance I won't forget about it over the next 3 weeks?
I'll do a simpler one. So like,
Yeah, mutable.
hi dot to string. Oh yeah, I didn't go over it in the actual chapter, but if you have a mutable reference to age, but not any other piece of the field, that means you can't use person as a whole, but you're allowed to use, or you can't use age either, but you can use first name and last name because they don't have a mutable reference. It knows that these ones are fine.
I don't understand. That'll be another other homework.
It's an extension of what we just talked about that you didn't understand, so I don't expect it to be easy to understand. Well, these don't compile, so we're deleting these.
You're late, indifferent.
I guess we can't do this. Can we just do equals? We're doing why that clear.
Fair enough.
Rust is lazily evaluated sometimes. Iterators are like .map. Okay, here we go. Here is an example that I have given before for your homework.
Okie dokie. What is this, chapter 5 homework?
Yep, it's more like chapter 4 homework extension.
Right.
But I will give this same question again next time, and we will go over it again.
Awesome.
Yeah, okay. I'm going to end the recording then.